90-degree columns can be implemented in piping systems in several scenarios. Firstly, to establish a corner within the piping network, 90-degree columns facilitate directional changes for pipes. This proves advantageous when navigating obstructions or constructing intricate piping configurations. Secondly, these columns can unite pipes situated at varying elevations, enabling vertical flow within the system. This is valuable for gravity-fed setups or connecting pipes across different building levels. Thirdly, 90-degree columns are essential for creating vertical risers, which are vertical pipe segments extending along a structure's side. Risers typically bridge horizontal piping systems to elevated building sections. Fourthly, they aid in forming headers, horizontal pipes positioned atop a piping system, which connect multiple pipe branches. When integrating 90-degree columns, several factors demand attention. The column's pressure rating should match or exceed the piping system's pressure tolerance. The column's dimensions must accommodate the piping system's flow rate. The column's material must be compatible with the fluid conveyed through the system. Adhering to these guidelines guarantees safe and efficient deployment of 90-degree columns. The selection of pipe fittings, including 90-degree elbows, also known as 90-degree columns in the context described, plays a crucial role in the overall functionality and safety of any piping system. Different types of elbows are designed for specific applications and materials, and it's essential to choose the right one for the intended use. Material compatibility is paramount. The material of the elbow must be compatible with the fluid or gas being transported through the piping system to prevent corrosion, degradation, or contamination. Common materials include steel, stainless steel, copper, PVC, CPVC, and PEX. Each material has its own set of advantages and disadvantages in terms of cost, durability, chemical resistance, and temperature range. Pressure and temperature ratings must also be considered. The elbow must be able to withstand the maximum pressure and temperature that the piping system will experience. These ratings are typically marked on the fitting and should be carefully reviewed before installation. Using an elbow with an insufficient pressure or temperature rating can lead to failure and potentially dangerous leaks or bursts. Pipe size and schedule are also important factors. The elbow must be the correct size for the pipes it will be connecting. Pipe size is typically measured in nominal pipe size, or MPS, while the schedule refers to the wall thickness of the pipe. The schedule must be sufficient to withstand the pressure and temperature requirements of the system. Different types of elbows offer different advantages. Standard elbows, also known as long radius elbows, have a radius of curvature that is 1.5 times the pipe diameter. These elbows offer low pressure drop and are suitable for most general purpose applications. Short radius elbows have a radius of curvature equal to the pipe diameter. They are more compact but result in a higher pressure drop. They are typically used in situations where space is limited. Sweep elbows have a larger radius of curvature than standard elbows, resulting in an even lower pressure drop. They are often used in applications where minimizing pressure loss is critical, such as in compressed air systems. Mitered elbows are made from multiple segments of pipe welded together. They are less expensive than standard elbows but offer higher pressure drop and are more prone to leaks. They are typically used in low-pressure applications where cost is a major concern. Installation techniques are crucial for ensuring a leak-free and reliable connection. Proper cleaning and preparation of the pipe ends are essential. The pipe ends should be free of dirt, grease, and burrs. Threaded connections should be wrapped with Teflon tape or pipe dope to ensure a tight seal. Welded connections should be properly beveled and welded by a qualified welder. Soldered connections should be properly fluxed and heated to ensure a strong bond. Support and alignment are also necessary for long-term reliability. The piping system should be properly supported to prevent stress on the elbows. The elbows should be aligned properly to prevent strain on the connections. Expansion loops or expansion joints should be installed in long runs of pipe to accommodate thermal expansion and contraction. Codes and standards govern the use of pipe fittings. Building codes and industry standards, such as those published by ASME, ANSI, and ASTM, specify the requirements for the design, materials, installation, and testing of piping systems. It's crucial to comply with these codes and standards to ensure the safety and reliability of the system. Regular inspection and maintenance are important for identifying and addressing potential problems before they lead to failures. The piping system should be inspected regularly for signs of corrosion, leaks, or damage. Loose or damaged support should be repaired or replaced. Expansion loops or expansion joints should be inspected for proper operation. Furthermore, understanding the principles of fluid dynamics is beneficial in optimizing piping system design. Fluid dynamics is the study of how fluids, both liquids and gases, behave in motion. These principles dictate how fluids flow through pipes and fittings, and understanding them is critical for designing efficient and reliable piping systems. Pressure drop is a key concept in fluid dynamics. As a fluid flows through a pipe or fitting, it experiences a loss of pressure due to friction and turbulence. The amount of pressure drop depends on several factors, including the fluid's viscosity, the flow rate, the pipe's diameter, and the fitting's geometry. Minimizing pressure drop is important for reducing energy consumption and ensuring adequate flow throughout the system. Flow rate is another important consideration. The flow rate is the volume of fluid that passes through a pipe or fitting per unit of time. The flow rate must be sufficient to meet the demands of the system, but it should not be so high that it causes excessive pressure drop or erosion. Velocity is related to flow rate and pipe diameter. The velocity of the fluid is the speed at which it is moving through the pipe. High velocities can cause erosion and noise, while low velocities can lead to sedimentation and stagnation. Turbulence is a chaotic flow regime characterized by swirling eddies and fluctuations in velocity and pressure. Turbulence increases pressure drop and can cause vibration and noise. Laminar flow, on the other hand, is a smooth and orderly flow regime characterized by parallel streamlines. Laminar flow minimizes pressure drop but is typically only achievable at low flow rates. Cavitation is the formation of vapor bubbles in a liquid due to a decrease in pressure. When these bubbles collapse, they can cause severe erosion and damage to the piping system. Cavitation is most likely to occur in areas of high velocity or pressure drop, such as at the inlet of a pump or in a partially closed valve. Water hammer is a pressure surge that occurs when a fluid in motion is suddenly stopped or changed in direction. Water hammer can cause severe damage to the piping system, including bursting pipes and damaging equipment. Water hammer can be mitigated by using slow-closing valves, surge tanks, or air chambers. There are several tools available for analyzing fluid flow in piping systems. Computational fluid dynamics, or CFD, is a powerful tool for simulating fluid flow and predicting pressure drop, velocity profiles, and turbulence. CFD can be used to optimize piping system designs and identify potential problems before they occur. Pressure gauges are used to measure the pressure in the piping system. Flow meters are used to measure the flow rate. Temperature sensors are used to measure the temperature of the fluid. These measurements can be used to monitor the performance of the piping system and identify potential problems. Finally, corrosion prevention strategies are crucial for extending the lifespan of piping systems. Corrosion is the gradual degradation of a material due to chemical reactions with its environment. Corrosion can weaken pipes and fittings, leading to leaks and failures. There are several strategies for preventing corrosion in piping systems. Material selection is a key factor in preventing corrosion. Choosing materials that are resistant to corrosion in the specific environment is essential. For example, stainless steel is highly resistant to corrosion in many environments, while copper is resistant to corrosion in potable water systems. Coatings and linings can provide a barrier between the pipe material and the corrosive environment. Common coatings include paint, epoxy, and powder coatings. Linings can be made of rubber, plastic, or cement. Cathodic protection is a technique used to prevent corrosion by making the metal surface the cathode of an electrochemical cell. This can be achieved by using sacrificial anodes or impressed current systems. Chemical inhibitors are substances that are added to the fluid to reduce the rate of corrosion. Common inhibitors include phosphates, chromates, and silicates. Regular inspection and maintenance are important for identifying and addressing corrosion problems before they lead to failures. The piping system should be inspected regularly for signs of corrosion, such as rust, pitting, or scaling. Protective coatings and linings should be inspected for damage and repaired as needed. Water treatment is necessary to prevent corrosion in potable water systems. Water treatment can include adjusting the pH, removing dissolved oxygen, and adding corrosion inhibitors. Electrical grounding is important for preventing galvanic corrosion. Galvanic corrosion occurs when two dissimilar metals are in contact in the presence of an electrolyte. Electrical grounding can prevent this type of corrosion by equalizing the electrical potential between the metals. By understanding these strategies and incorporating them into the design, installation, and maintenance of piping systems, engineers and technicians can significantly extend the lifespan of the system and prevent costly failures. The proper application of 90-degree columns or elbows, along with attention to material selection, fluid dynamics, and corrosion prevention, ensures the reliability and efficiency of any piping system.